Today we are going to do section, this is 7.2, the systems of equations. And now we're going to do 3 equations and 3 unknowns. Now before I start, I want to mention briefly the coordinate system that the book doesn't seem to want to talk about for some reason. Okay, now the coordinate system normally we have is something called the XY system. That is, we have, for example, something like this. This is X and that's Y, and you can pick a point on there, say that's 1, 1. Okay, and that's the normal system we have. Now this is a 2-dimensional system in the sense that everything's on the same plane. Now there is also a 3-dimensional system that looks like this. Okay, that this is X, this is Y, this is X. Why is X slanted? That's because X is coming out straight out of the board. Okay, and and there's a third one that's called Z. Now that is that's a 3-dimensional system that I'm talking about. This is a right angle, this is right angle, and so is this. This is all 3 right angles. This is like looking at the corner of a box. Now in the 3-dimensional system, then we have something like, well, like this. Okay, I have can you see this okay? I guess maybe I should pick the colored thing. Yeah, this wire is silver. Well, anyway, see, you can kind of see that. Okay, like for example, you can pretend that this is the x-axis that's coming straight out at you. Okay, well, the y-axis going to the side and z-axis is going up, and that's a 3D system. And if there a point on there will have 3 coordinates, unlike this one with 2. For example, a point right here, the 1, 1, 1 point, will be it'd be kind of hard to draw, but you get the idea. It'd be somewhere over here. If I turn it, you might see it better. Well, whatever. So that is the 3D system. Now on the 2-dimensional system, we have lines, right? For example, like a line such as x plus y equal to 1, a standard line. And you can draw that line if you plot it on there in some way that you learned. Now the 3-dimensional system will have something like this, such as, for example, x plus y plus z equals to 1. Now what is that? That is not a line. In the 3-dimensional system, that ends up being a plane if you were to plot it. And of course, plotting it is not going to be an easy matter, okay? And so right now, we're not going to talk about plotting this thing. I just want to explain this briefly that, remember, the 2D, that just with 2 variables, when you add stuff together, that is a straight line. And then, but if you have 3 variables that's added together like this, maybe with some numbers in front of them, okay, but generally speaking, just x, y, and z added or subtracted can be a negative number. Then that will give you something called a plane. A plane is a perfectly flat surface that's going whichever way it's supposed to go. Now, as an example of that, and this kind of equations is what we're dealing with in this section. So that's why I want to briefly mention that. Now, please look at page 702, okay? And the book has shown you some pictures of these plane systems. Now, for example, if we have 3 equations and we are trying to solve them, ideally they'd be looking like this. That is, the three planes cut each other at such an angle that they intersect at only 1 point. And if that's the case, then we have a solution, okay? Then, however, that might not be the case. For example, the 3 planes might intersect like that other thing, okay, where it intersects along a line, which means it has a ton of solutions. Next, the 3 planes might not intersect at the same point at all. 2 of them might intersect, but all 3 of them don't intersect at the same place. So you have this situation or this situation, or worse, all 3, in this case, only 1 plane intersects the other 2, right? But the other 2 are parallel. Or you can even have all 3 planes parallel. It all depends on your equations and how they are arranged. But I just want to give you a quick idea. You don't have to know how to plot these things into a 3D system at all. I just want you to have a vague impression, okay, that when you have numbers something like this, except that there's 3 variables, like this one, or this one, or this one, then each one of these things define a plane in 3-dimensional space that looks like one of these things. So having said that, let's look at example 1 on this page. Now example 1, it just asks you to decide whether the 3 numbers is a solution to the system. So the example 1, we have the 3 numbers already given to you. They just want you to verify it. For example, that is, if x is 3, y is minus 2, and z is 1, does x plus y plus z equal to 2? Now if you do that, 3 minus 2 plus 1, that is equal to 2, right? So that one's done. And then you verify the other 2 in a similar way. So I won't be doing that. And so please do that yourself. And that is example 1. I'm going to move on to example 2. Okay. Now we are going to do the solve this thing and find the answer that we were given in example 1. So now we have to find this stuff ourselves. Now and that is what this section is for, is to teach you how to solve 3 equations with 3 unknowns. Okay, and that is so I'm going to follow the book exactly, okay, because I have a tendency to make mistakes when I do this kind of thing. So I don't want to waste too much of your time making too many mistakes. So what we're going to do is we're going to write down the equations, give them numbers. This is minus x, let's see, all right. So we'll name the equations like the book does, equation 1, equation 2, and equation 3. Now having said that, then we are going to take equation 1 and look at that, there's x and there's minus x. Just like the last section, we're going to add these 2 equations together and then we'll happily get rid of the x. Okay, so let's add it together, then we get 0x. So I will, right, so x is gone. So then this together becomes y, and then plus 2z, and that equals to 9. All right, so that is, let's see. Did I get it right? No, sorry. See, I already made a mistake. It's 9 minus 6 is 3. 9 minus 6 equal to 3. I forgot to do the minus 6. So when you add the equation, this add that, right? This add that is y. That add that is 2z. And 9 minus 6 is 3. So that is, okay. That we will call this thing, well, anyway, so next we are going to take the equation, let's see, where's this? We're going to take equation 1 and multiply it by minus 2. The reason is because we're going to use equation 3 and equation 1. If we multiply this by minus 2, that'll get rid of the x from this one and this one. So first we use first 2 equations. Now we're going to use the first and the third equation to come out with something else. So equation 1 multiplied by minus 2, that would be minus 2x, okay, plus 4y times minus 2, that's minus 6z, equals minus 2, that should be minus 18. Okay, and then copy down equation 3, we'll just copy it down here. So we have 2x minus, actually, I'm not going to copy it down. I'm just going to add them together, okay, so that we don't do so much writing. So adding this equation to equation 3, we get, we get what minus 2 is canceled out, right? Plus 4 minus 1, that's minus y. Yeah, I think that's right. Minus 6 plus 5, that's minus z. Okay, and then this and this becomes minus 1. So yeah, so far so good. And we'll call this equation 5. Okay, so now we have equation, this thing has a name. The book calls it, what does the book call that thing? The book calls this one 3 as well. To be consistent with the book, we'll also call it 3. Okay, even though this one is also called 3. But doesn't matter. So we will, or maybe the book calls it 4. I guess later the book calls it 4, so we'll change it to 4. That's better, because we shouldn't call the 2 things the same name. Which cause confusion. So we are going to take care of equation 4 and equation 5 by, we're going to add them together because there's a y and there's a convenient minus y there. So we're going to add these 2 things together I'll even write it down. So 4 plus 5 give us, so y minus y is nothing, right? And then plus 2z minus z, that's just z. And then 3 minus 1 equal to 2. So I got z equal to 2, and we'll call it equation 6, as the book does. The reason of naming all these equations numbers is so that it gets a little less confusing. Then we know what we're talking about. That's sort of reason. Okay, so that is a big break. Okay, with z equal to 2, then we can plug it back into something. We'll first plug it back into this one, because that gives us a quick shot at figuring out what y is. Now, since z equal to 2, then y is equal to, from this situation, equation, which is equation 4, I'll write it down. From equation 4, y equals to 3 minus 2z, which is 3 minus 4, right? Z is 2. That would be 1, minus 1. Okay, so y equals to minus 1. All right, so far so good. And then eventually, the only thing we have left now is figure out what x is. And so we'll plug it into equation 1 or 2 that has x in it. Let's see, what does the book want? The book wants to plug it into equation 1, which is fine. So to plug this information, z is 2 and y is 1 minus 1 into equation 1, we have, see, there's equation 1. Equation 1 says x equal to 9 minus plus, okay, put the y on the other side, plus 2y, and then plus 3z, right? No, minus. When you switch things over, it better be minus. So it's plus 2y minus 3z, because I'm moving them to the other side of the equation, plus and then minus. Okay, and there's the 9, so I think I got everything taken care of. Okay, so next, continue calculating. We know what y is, so 9 plus 2 times y is minus 2, and then minus 3 times 2 is 6. And that becomes 9 minus 8, which is 1. Okay, I got 1, which is correct by the answer in the book. So that is the solution then is 1 minus 1 and 2 on the next page, where the book even draw the 3 planes to show you. Like I said, you don't have to draw the 3 planes. You haven't been taught how to draw these things. And yeah, anyway, the point is that these 3 planes end up being intersecting at exactly 1 point, which is how we want it. All the other intersections, there's not a single solution, and which means they are headache. In other words, there's no real answer to the question. All right, so that is example 2. Next, let's look at page 704, example 3. Now, let's consider somebody who invested $12,000. Okay, so in this problem, I'm just going to write down the numbers without the thousand. So our unit will be thousand. Okay, each 1 means 1,000, and 12 means 12,000. So the money is being invested in 3 ways. So let's call them x, y, and z. So the first equation is that x plus y plus z equal to 12. Now don't forget 12 means 12,000. Otherwise, once we get the answer, we need to add 3 more zeros to it. Okay, so the money, 12, is being split up 3 ways, and we don't know how exactly, but it will read it. Okay, x will be the money market fund, which pays 3% interest. So x will take x times 0.03, 3% interest, then is, yeah, 3% interest. And that's y, we'll call it the, x is what? Money market fund. Yeah, y, we will call it the, what is this? Municipal fund. So 0.04, 4%. So the second money will do the 0.4%. And the rest of the money is making 7% plus 0.07. That is awful. Okay, 0.07 times z, and All right, so that is all the money that this stuff made. And it says the total interest earned is $670. That is 0.67 thousand. Okay, 670, right? And then finally, the last piece of information says that the 4,000 more was invested in mutual funds. Mutual funds is Y. Okay, that's the mutual funds. So Y has 4,000 more than in the municipal. That's the no. Let's see who's sorry. Z is mutual funds. That is Z and the Y is related. That is Y is bigger than Z. Y minus Z is equal to 4,000. We'll write down 4. Right? Let me make sure our money is correct. So X is the money market fund, money market. Okay. Y is the municipal bonds. So we'll call it MB. And then Z is mutual funds. We'll call it MF. All right. So and then it says the 4,000 more in mutual funds. Did we say mutual funds? Oh, this one. 4,000 more in mutual funds than in municipal bonds. So this is more than that, right? I think I got this wrong. It says some 4,000 more in mutual funds, that one. So Z is bigger than Y. That is Z minus Y is equal to 4 because Z is bigger than Y by 4,000, that is. All right, so that is the question. All right, so now that we have that straightened out, let's look at what are we going to do with it. Okay, first I will follow the book's way of doing things. That way I can catch myself with mistakes. Okay, the first thing we want to do is there are too many zeros here, so we're gonna get rid of the decimal point. See, there's a decimal point in every spot, right? And so we're gonna push the decimal point 2 spaces for each value. So in other words, multiply this whole thing by 100 to get rid of the decimal point. So the first thing move the decimal point 2 spots for each slot. So then this becomes 3x, okay, plus 4y, and then plus 7z, and that equal to 67. Right, because that got moved to as well. All right, so far so good. And then we are going to, the next step at the bottom of the page, we're going to multiply equation 1, which is by -3. Which one's equation 1? It would be, and add to equation 2. All right, so this is equation 1, and this is equation 2. And this thing will be equation 3. So then if, well, anyway, let's add this and that, okay? Is that right? Yeah, that looks about right. But first I think we have to multiply by something first. Let's multiply equation 1 by -3. That way we can line it up with the +3 here and get rid of it. So multiplying equation 1 by -3, we get minus 3x minus 3y minus 3z equals to minus 36. I'm writing it a bit close. Oh well. And now we're going to add up these two things, okay, to get rid of the x part. So then 4 minus 3 is y. That is just 7 minus 3 is 4z. Yeah, right. And then equal to 67 minus 36, that should be 31. Okay, now let's see. So we got y plus 4c equals to 31. All right, so so far so good. So we got this equation. And the next part is we already have an equation like this. that is, we already have an equation that is, then I'll pull the lid off the marker. I'll underline it right here. This thing right here, okay? Right here, c minus y equal to 4, and then y plus 4z equal to 31. And we're going to focus on these two things because that is how we're going to nail one of them, okay? So let's add these two things together. And because there's a minus y there, right? So we can get rid of it. And so so the y's disappear. Z plus 4z is 5z. 5z. And then the n, 4 plus 31, that's 35. So z equal to 7. Yay! That is a very good point to be, okay? The fact that we find out z is 7. That is, yeah, because from this point on, things become much more pleasant, okay? Once z is 7, then we get y out of, say, here. Doesn't matter, you can get y out of here or here. It will be the same. It better be the same. If it's not the same, that means somebody screwed up. And so anyway, so z is 7. Let's plug it in here, okay? Then we get from this equation, we get z minus 4 equals to y. Okay, I move y over here and move the 4 to the other side. So I got this thing. And then z is 7. So plugging in z equals to 7. 7 minus 4 is 3. So my next answer is that y equals to 3. Okay, and then finally, so we can plug in, now we have two pieces of information. Z is 7 and y is 3. Well, let's plug it into this one. Okay, so then x equals to 12 minus y minus z. I got that from here. Okay, moving y and z to the other side of the equation. And then what is, so that means 12 equals to 12 minus y. Where's y? Y is, that is, I better write it down so I don't mess up. 12 minus y is 3 and c is 7. Okay, that would be, means x equals to 2. So that should be, yep, and that is correct. So that is finally our answer. So the answer is x is 2,000, okay, don't forget the zeros, and y is 3,000, and z is 7,000. Let's add all the zeros. And of course, if you are doing this for school, you have to, well, we already specified what they are. I just mean that you have to specify it, you know, the MF is 7,000 and the MB is whatever it is, that sort of thing. It's taking care of some housekeeping. But generally speaking, that is, we got the right answer, okay? And all right, so that is, that's example 3. And next, let's look at something that has a problem. That is, we have a similar thing like this with 3 equations, but the problem is we might encounter one of those situations, that is that the 3 planes don't intersect at one point. That is, we might encounter one of this, that, and or that. And that is example 4. So here is example 4. We have these 3 equations. Let me double check, make sure I wrote it down correctly. X minus 3y plus z equals to 4. Negative x plus 2y minus 5z equals to 3. And 5x minus 13y plus 13z equals to 8. Okay, that should be good enough. And the first thing we do is noticing that there's an x here and there's a negative x here. A good point to attack. Okay, so the first thing we do is add equation 1 to equation 2. 1 plus 2. Okay, and that will give us, this will cancel out. That will become negative 5y. And then plus minus 4z equal to 4 and 3, that should be 7. Okay, and that is minus, no, I'm already getting it messed up. Why? Oh, negative x plus. I didn't see that. This is a plus. Okay, and plus, then it's not minus 5y, it's only minus y. That's a good thing I notice. I'm keeping track of this. See, I'm checking myself at every point. That way I don't mess up, because I don't want to waste too much time messing up here. Okay, and so that's that. We'll call this equation 4, as the book does. So let's turn to the next page. And then next we multiply equation 1 by minus 5. So we want to multiply this thing by minus 5 and then add it to this because there's a positive 5 here, so we'll cancel it out. So let's take equation 1 and multiply it by minus 5. Minus 5 times equation 1, that gives us, we'll write it down first, okay? Equation 1 times minus 5, that's minus 5x plus 15y minus 5z equals to minus 20, okay? And then we'll add this thing to equation 3. To add this to equation 3, the minus 5x will disappear. We have plus 15 minus 13, that's 2y. And then minus 5 plus 13, that's plus 8z. And that equals to, what are we doing again? This plus this, right? Yeah. So that would be minus 12. Minus 20 plus 8, minus 12. Okay, so we'll call this thing, does this thing have a name? Let's check. 2y plus ac, we'll call this thing equation 5. All right, so now we have equation 4 and equation 5 that only have 2 variables each. Okay, so that is, by now, 2 variables is like, oh wow, that's a piece of cake compared to having to deal with 3 variables. So we're going to solve these two things together by the 2 variable trick. What we're going to do is, first we'll multiply this equation 4 by 2 to get rid of the 2y. See, it already has minus y there. So if we multiply by 2, we will have minus 2y and then minus 8z, that equals to 14. And then add this equation to this one right here. Maybe I should have written that down there. Anyway, so that the y becomes 0. So we have minus 8z plus 8z, that becomes 0z. Okay, now we have an odd situation because both y and z disappear. Now what? Okay, so that equal to, that's minus 12 plus 14, that's 2. So we have 0 equal to 2. And now what do? Simple. We do nothing. Okay, 0 equal to 2 is not possible. Therefore, there is no solution to this problem. The end. That's the end of this this entire thing. It end up being that's because these 3 equations end up being one of those things that don't all intersect at a nice little point, like we saw earlier. That is, these systems, they are like, I think the book says they are like this or something. Yeah, they're probably a situation like this, but we don't care. The point is they're not this, and this is the only one we want, okay? All the others have either too many solutions or no solution, period. And too many solutions means we don't know the answer. There's still no answer to our problem. Anyway, so that is example 4. Next, let's look at example 5 on page 706. Now we have equation 1 and equation 2 and 3. Now look at these equations carefully, okay? We have 2x plus y minus 3z. And then what is the second equation? It says 4x plus 2y minus 6z. Equation 2 is the same as equation 1. It's just multiplied by number 2 is all. Then otherwise they're exactly the same thing. Okay, if you multiply this by 2 across the board, you will get, of equation 1, you get equation 2. So that means we don't have enough equations. There's a fake one right here that's actually the same thing as equation 1. So in other words, we're going to have an infinite number of solutions at that point. Being that we only have, basically we have only 2 planes here. Now to solve this kind of thing, well, at least the third one isn't a multiply of the 2. I mean, it could be. The third one might be some other multiple of the third, so that all 3 planes is actually the same thing. But the third one apparently isn't, because the number in front of y changed signs from here. You know, it's a minus instead of a plus, so that's helpful. And so as a result, we will try to solve say these 2 equations and then come up with some kind of a relationship, okay, or something. Let me see what the book does, and we'll do exactly what they want to do. So first, we're going to take equation 3 and multiply it by -2 to work with the equation 1, because we're going to come up with some kind of an answer. Okay, so it's called a parametric representation, and the book doesn't really call it that, but that's what the book is going to do, and so we're going to do the same thing. And what we're going to do is first multiply equation 3 by -2. Okay, so 3 times equation 3 is being multiplied by -2. Don't forget the minus, so that it can cancel out with that thing. So multiplying it by -2, we get -2x plus 2y, and yeah, okay, minus 2z, and that equal to 0. And so then when we add this up, we get 3y, and then what is that, minus 5z equal to 0. What? And now give me a second here. Did I? Oh, never mind. Now, there's nothing wrong with doing that, but the book doesn't want to do that, and I want to stick with what the book is doing. There's more than one way to skin the cat, but for now, we'll just stick with the book's way of doing things, okay? And so that I don't, mess up so much. Now, so we're going to do this other thing instead. We're just going to add this directly, because I didn't notice that there's a plus y and a minus y here. So we can get rid of the y without multiplying anybody by anything. Okay, so let's do 1 plus 3. Equation 1 plus equation 3. That gives us, the y's disappear. We have 3x, and then minus 2z, and that equals to 0. And that will give us, yeah, that's good. And that will give us this thing. Z equals to, you put the z on the other side, okay? Yeah, and then do some division. Z equals to 3x over 2. I changed sides. So put the z on the other side, then 2z equals to 3x, and then drop the 2 down. So z equals 3x over 2. So we got z out of here. All right, and then we are going to put this into one of these things. Which one do we put it in? We'll put this equation, this z value in here to solve for y in terms of x. And so what we're going to do is put this information into equation 1. Okay, I'll put it arrow into equation 1, that information. So we get 2x plus y minus 3z, 3x over 2, and that is going to be equal to 0. All right. So then we have, now we are going to solve, then y equal to, now throw every x on the other side, okay? So the 2x becomes minus 2x. This thing becomes plus on the other side of the equation, plus 9x over 2. And that will be equal to 9 minus 4, that's 5x over 2. Okay, but that's, and what about it? So the answer, now notice how the answer is written. The answer then is called x, comma, x, we don't know what x is, okay? And then y is 5x over 2, 5x over 2, comma, and then z is 3x over 2. That's the answer if all the answers are given in terms of x. Now you might think, why is every answer given in terms of x? What if suppose we could put it as y something y something y something y, or something z something z something z? You can't. But right now the book says choose y, so choose x, so that's what I'm sticking with. This kind of problem isn't that exciting in this course. I think the books just want to show you that it can be done. So what does this mean? This means some kind of a straight line that is like this. Look at these two planes. The two planes intersect at the straight line, and that is the description of the line. That is, if you input a number like 1, x equal to 1, then you get some numbers, and that's part of the line. If you input x equal to 2, then you get 2 something something, and that's another point on that straight line. But We don't care about that right now, okay? We're not going to go into that. Right now, we mostly want to focus on the equations that actually has a solution. That's what we are most interested in. So, but just be aware that these other situations happen, and yeah, that should be good enough for anybody. All right, so that's the end of this section. We're not going to have a lot of homework because each homework is going to take quite a bit of time, and you might find yourself being stuck with mistakes and that has just because of a dropping something. Yeah, hopefully you're the kind who don't make that kind of mistakes. But for me, I make all kinds of mistakes doing this type of thing because I always forget to subtract, minus, and so it can be very, very tedious to do. However, so please allow yourself some extra patience when you do the homework. The goal of doing the homework is just so that you learn how to do this. The goal is to use two of the equations to eliminate one of the variables so that you have only two variables left, and then you solve it like the two variable system in the previous section when we had such a nice time, okay? With three variables, then you have to go through all this extra work, and so it's much more painful. And then there are, of course, four variables and four equation system, which gets even more painful, but that's hopefully in the distant future. Now, in the meantime, we're going to do some of the homework in this section. So please first do all the examples. Make sure you understand how they are done. They're pretty straightforward, really. And plus, remember, there's more than one way to skin the cat. Because, for example, you can eliminate, instead of eliminating x, you might decide to eliminate z. No reason. Some people like to eliminate z better. So when it comes to systems of equations, there is more than one way to do it. But hopefully you choose the easiest way to get to the result without getting lost in the way by dropping a negative sign or something, and then your whole thing goes to pot. If that happens, just pick yourself up and try again. All right, so let's look at the homework. So for homework, please do on page 708, problems 11, 15, 21, 25, 29, 51, 53, and 59. I mostly pick problems that I feel that will be more beneficial for you to do. The ones that have no solution or the one that have make you do this, I don't really feel that you should be doing this right now. Okay, you should focus on how to solve, learning how to solve the system of equations when a solution is available. So that will be our focal point. So please do your homework and be sure to go over the examples, especially the ones that tell you how to do it. Now, the homework section sometimes says use the word elimination, which is this trick we just used, and they also mention something about Gaussian elimination. That's just the name for the mathematician who came up with this trick of how to solve this stuff. So anyway, please do this stuff carefully. I know it's gonna be very tedious, probably. Okay, I mean, I'm sure not looking forward to doing it, but please give yourself some patience and get the homework done so that you feel you're familiar with how to solve this kind of stuff. Once you get a hold of it, it's really very straightforward. The only problem is, for me anyway, is I keep messing up and then I get stuck somewhere and can't find my way out because there's so much to do. It's often hard to figure out where I messed up. But as long as you do it very, very carefully and don't mess up, then you get to the right answer without spending too much time, actually. And I will talk about the homework problems in the next video.